Piping and instrumentation diagrams are schematics that play an important role in designing a chemical process. They show pieces of important equipment that are connected together, as well as which instrumentation is used to control various aspects of the procedure, such as flow rates.
Normally, larger units such as distillation columns or reactors take the spotlight in the design process, so it's easy for the small guys such as pumps, valves and compressors to be overshadowed. So let's head to the labs and see what makes these things hidden heroes.
So here we are, the great lab.
This is a piston compressor. A piston compressor uses a piston and a cylinder to compress gas. Piston compressors are useful when high pressure gases are required, as they can produce pressures of over 400 bars. That's right kids, 400 bars. However, piston compressors have high maintenance costs and poor mechanical efficiency due to its moving parts. Compressors can be identified on a PNID by the following symbol.
This is a wedge gate valve. It is an on-off valve with good shut-off characteristics and minimal pressure loss when a fluid flows through it. However, it is not very quick in opening and closing, requires a large space for installation and operation, and is subject to wear and difficult to repair. Valves can be identified on PNIDs by two horizontal triangles pointing at each other. They are commonly used in industries like sewage and oil and gas, where valves are not easily accessible to be cleaned, as the smooth interior of the valve means there is no sediment accumulation.
This is an angle seat valve. It is a control valve which is easy to maintain and repair and has a shorter open and close time than the wedge gate valve. However, it is quite pricey, and compared to the wedge gate valve, there is more pressure loss. They are commonly used in the food and pharmaceutical industries. Now that's out of the way, let's go over how to construct these valves.
For the wedge gate valve, first take the spindle and attach to the gland screw. Place a washer on the spindle before attaching it to the upper housing section. Screw this into place until tight. Next, take the hand wheel and with a hexagonal screw and fender washer, attach it to the upper housing section. Place a spindle nut inside the gate and screw this onto the bottom of the spindle. Finally, attach all of this to the main housing, screw firmly into place, and you're done. Wedge gate valves are on-off valves that work by descending a wedge perpendicular to the flow.
For the angle seat valve, first take the extension and screw the hand wheel into place. Next, place the hexagon nut on the spindle and attach it to the previously made piece, securing them with the threaded pins. Finally, screw all of this into the housing until tight, and you're done.
Angle seat valves are control valves which work by descending a plug parallel to the flow onto the seat to block the flow. The flow rate is dependent on how far the plug is descended.
Hopefully this video has given you a brief insight into the importance of these often forgotten outstrung components of chemical processes. Thank you for watching.